IncPy is a modified version of the Python 2.6 interpreter that automatically memoizes or caches the results of long-running function computations to disk and then reuses those results later when safe to do so. I'm going to demonstrate some of IncPy's basic functionality with some demo scripts. In our first script, we have a function foo that simply takes an x and returns its value squared. Now I've added in this time.sleep of 3 seconds to simulate the fact that a function that you might actually want to memoize will often take a long time to run, maybe a few seconds, maybe even a few minutes or hours even. So if we run this foo twice in regular Python with the same argument of say 10, then what happens is that Python will take 3 seconds to run each call to foo. But if we run it in IncPy, the first call will still take 3 seconds, but then IncPy will memoize the return value of 100, 10 times 10, to disk, so that the second call can simply be skipped, and the return value of 100 can be reused. So let's see how that works. So if we run demo1.py with IncPy, we have to wait for 3 seconds, it'll return 100, and now the second call, you notice, returned instantly and was skipped. So IncPy creates a log file that we can use to see what it did during an execution. So the first call to foo ran for about 3 seconds and it was memoized. And the second call to foo was skipped altogether because it could just simply reuse this old value of 100. Now if we run this demo1py again, notice how both calls are instantly skipped because the value of 100 is still valid. So what happens now when we change the code to foo? Let's say we want to compute x cubed instead of x squared. Now clearly this old cache value of 100 is no longer valid because we actually want to compute 1000 now. So IncPy knows that the code has changed and actually clears the cache entry. So it will actually run for 3 seconds again, create 1000, and then the second call can be skipped. So if we look at the log file, we see that it says that a code dependency has been broken. The code of foo has actually changed so that its cache must now be cleared. Now we're going to run as usual, take 3 seconds, memoize foo, and the second call is skipped. And now, with this new version of foo and this new save value of 1000, we could rerun this however many times we want, and it'll keep on skipping it and reusing that value of 1000. In the second demo script, I want to show what happens when a function reads from a global variable. So in this function, foo, x is multiplied with some global multiplier. So again, when we run foo for the first time, IncPy will take 3 seconds to run and then cache its return value, which in this case is 50, 5 times 10. And the second call should be skipped. So just to make sure that does what we want, we run it, wait for 3 seconds, return 50, and then the second call should be skipped. No surprises there. And in the log file, it shows memoize, then skipped. Now if we run again, both calls should be skipped. But what about if we tweak this global multiplier? Let's say we change it to 50 now. Clearly we can't simply reuse this old result because now the answer should now be 500, right? So IncPy knows that the global has changed and it will actually rerun it to get a new result. So now we wait for 3 seconds and we get 500 as a new answer. So again, this will keep on being skipped as long as this value is 50. And if we want to change it back, we can just change global multiplier back to 5, and IncPy still has that old value of the global multiplier in its cache, so we can still skip the calls. Notice here, they just return instantly, and the calls were all skipped. So the last demo I want to give is what happens when a function reads from a file. So in this function, count words, it takes a file name string as an argument. It iterates over the file, the open file with that name, and for every line in the file, it counts the number of words in that line and increments num words, and finally returns the total number of words in the entire file. So if we run count words with a file called input.txt, let's see what happens. So first let's view what input.txt is. It's simply a file with 12 words in it. So this call to count words should run for 3 seconds, again, because of our simulated delay. So this could, in a realistic case, this maybe we're processing a large file, so it actually did take a few seconds or maybe a few minutes to process. So when we run count words, it should return 12 and print it out. So let's run demo 3. Again, we wait for 3 seconds, our simulated delay, and it will print 12. And now if we run again, notice how it just prints 12 instantly, no matter how many times we run it, because the count words function has been skipped, because of the fact that this input file has not changed, right? And if this input file has not changed, and the code to count words has not changed, and it also doesn't even read any global variables, then no matter how many times you run this function with input.text as an argument, it will always return 12. So there's no point in rerunning it. So, but what happens if we actually do change this file? So let's say add a new word called 13. So there's now 13 words in that file. We save it, and now when we rerun, we simply can't reuse the old value of 12, right? Because the actual answer now is 13. So IncPy knows about this, and it knows to recompute because the cache entry is no longer valid. And now we get 13 again. So if we look at the log file, we see that it says a file read dependency has been broken. Input.text has changed. So the function count words depends on an input file called input.text, and if that file is changed, then the old cache results are no longer valid. So now it's rerun, and the new result of 13 is memoize. So again, we can rerun this as many times as we want, and now the answer will always be 13 until we change that input text file once again. So that's the basic functionality of IncPy in a nutshell. I'd encourage you to check out the web page for full documentation on all of IncPy's capabilities. Thank you very much.